All right, guys, today we're doing division lesson 15. Just a little bit different from yesterday's division practice. So I'm going to go back to the division facts. If you can figure out 30 divided by 5, thinking of it as a multiplication problem might help. 5 times what is 30? So you've got this fact family here. You've got to figure out what's missing. Well, 5 times 6 is 30. So 30 divided by 5 must be 6. If you can find those facts, they lead you to finding a division problem like this. 31 divided by 5. Same concept of 30 divided by 5, except for you're getting one more. That one more can't be split into these 5 groups, so it then becomes a remainder. So the quotient is still 6, but that one more becomes the remainder. So again, using your facts, your multiplication facts to solve division facts, using your division facts to solve division facts with remainders. Let's check out another one here. So this time we're going to start with a fact that doesn't go in equally. 7 does not go into 43 an equal amount of times. So we know that there's going to be a remainder. We need to start to think about our 7's facts. And if you have your 7's facts memorized, you'll know that 7 goes into 42 6 times. And 42 is the closest number to 43 that we can get without going over 43. So I'm going to rearrange this multiplication problem into 42 divided by 7 is 6. This division problem will help me solve this one. They're very, very similar. If I have 42 kids in my class and I put them into groups of 7, each group will have 6 kids. Same concept, except for now I've got 43, one more student. Can I split that one student into 7 groups? I can't. So the answer remains the same. The quotient is the same. It's still 6, but that one more student that I added one more, now becomes a remainder. So I look at the difference between these two dividends, they call them, and that becomes my remainder. Let's see how we're going to use that for practice today. So this time you are going to see some division problems. You're going to find the quotient and the remainder. You're also going to graph or put them on this grid, and I'll show you how we do that using the area model, thinking about how length times width equals that area. So let's take a look here. We've got 24 divided by 4. You can think of some multiplication facts like 4 times what makes 24. If you have your facts down, you'll know that will be 6. So then you can rearrange this multiplication into a division problem. 24 divided by 4 is 6. And it goes in there exactly. If I skip count by 4s, I do it exactly 6 times until I get 24, and that 6 becomes my remainder. That's my quotient, sorry, but I don't have a remainder because it goes in there exactly 6 times. Another way to think about it is using this area model. So if I have 24 dots and I want to split them into 4 groups, I'm going to make 4 groups, 1, 2, 3, 4, and I'm going to keep going until I see how many dots go in each group. Right now, each group, 1, 2, 3, 4, has 1 dot, but I'm going to keep going because I have 24 to give out. There's 2 groups, which is 8 dots total. There's 12 dots. There's 16 dots. 20 dots. There's 24 dots exactly. So if I were to turn this into a rectangle, it would look like this. It would be a 4 by 6, and there's my 24 dots inside. Can you show 24 divided by 4 with just one rectangle? Yes, I can. There's no remainders. It makes exactly one rectangle. Perfect. What if I added one more dot to this? So now I've got to think of it as 25 dots divided into 4 groups. I'm going to make my 4 groups, And I'm going to pass out these dots equally. And there's 12, 13, 14, 16, 20, 21, 22, 23, 24. And now I've got an extra one. So check out my rectangle has changed. Here's my original. Here's my remainder. So I know it's still a 4 by 6, but there's that one more dot on the side. I know 4 by 6 makes up 24 dots here, and here's one more to make 25 dots. So my quotient is, I know if I have 25 dots and I split them into 4 groups, each group is going to have 6 dots. 1, 2, 3, 4, 5, 6 in this group, and 1, 2, 3, 4, 5, 6 in this group, and so on. But I'm going to have one remainder. And we put that R1, remainder 1. My quotient is 6. My remainder is 1. Can you show 25 divided by 4 with one rectangle? No, on this one I can't. And it's all because of this rectangle, this remainder, that's attached to my rectangle. Some other practices you guys are going to try today. Similar idea, but you're going to use an array and area model. And these are going to look very, very similar. So they gave you the problem 25 divided by 3. They used 25 dots. They put them in groups of 3. And they wanted to know how many groups total. Well, here's my 3 dots, 3 groups. And there's 1, 2, 3, 4, 5, 6, 7, 8 on each. So a 3 by 8 makes 24 dots. Here's my one remainder. My quotient, how many are in each group? 8, with 1 left over. Then they made these with dots. Then they went over and just gave a real rough rectangle. It's still the 3 tall, 8 wide, just like this is 3 tall and 8 wide. And then they added that one remainder to the extra here. Let's take a look, as I'm going to do the same thing with 44 divided by 7. So I'm going to do 7 groups. 1, 2, 3, 4, 5, 7. And then I'm going to do it until I get rid of all 44 dots. So there's 1, 2, 3, 4, 5, 6, 7, which is 14 dots. 21 dots. 28 dots, and I'm just skip counting by 7s. And then 35 dots. And there's 42 dots. 43, 44. So if I look at my work, it is 7 tall, 1, 2, 3, 4, 5, 6 wide, and these 2 are my remainders. So my quotient is 6, remainder is 2. Quotient is the side of my array that I didn't count. See, the 7 is already counted here. It's this side plus 2 more. This chunk has a total of 42 dots, because 6 times 7 is 42, and here's 2 more to make 44. Then you come over, make your rectangle, just really, really simple. We know it's 7 tall, 6 long, and it has 2 remainders on the end. And that shows you the 42 dots. Hopefully this helps you with today's math, guys.